In the previous video, we focused on how LLMs use context, instructions, and memory, but LLMs have a fundamental limitation. Large language models generate text, but they do not have access to current information in the world, and for many tasks, existing tools like calculators or search engines are far more relevant because they are built for that specific purpose. Some example questions or actions that LLMs cannot handle on their own are: what is the latest stock price? Send this report to the team. Search this repository and fix the bug. By themselves, models cannot complete these tasks. This is where the concept of tool use comes to the rescue. By connecting an LLM to tools such as search APIs, vector databases, code executors, calculators, or custom services, we give it capabilities far beyond pure text generation. Tool use enables agentic AI systems to access up to data information, perform actions in the real world, and complete tasks autonomously. Let's take a closer look. To use external capabilities, the LLM needs a way to call them. And this is where the idea of a tool comes in. A tool is any external function the model can invoke to get information or take action. It could be a calculator, a search API, a database lookup, a code executor, an email sender. Anything the model can trigger when needed. In practical terms, a tool is defined by 4 parts: a function, what the tool does; a structured input format, what information it needs; a structured output format, what it returns; a description, written in natural language so the model knows when to use it. The description matters. The agentic AI systems reads it, understands the purpose of the tool, and decide if a tool call is necessary. The clearer the description, the smarter and more reliable the tool selection. Most tools fall into 2 broad categories: information tools and action tools. We'll look at both later. When the model decides that a tool is needed, it doesn't execute it directly. Instead, it responds with a tool call, a structured message that contains the name of the function and the arguments it wants to pass. The agentic AI application receives this tool call, runs the actual Python function, and then sends the result back to the model as a new message. The process looks like this: 1. Check whether the model requested a tool. 2. Extract the arguments. 3. Run the real function. 4. Send the result back into the conversation. And 5. Let the model form the final answer. This pattern turns a language model into a real agent. It can decide when to use a tool, call it with the correct parameters, and then continue reasoning using the result. Information tools allow the model to retrieve or look up data that it does not have. Large language models don't have access to the internet, databases, or company knowledge by default. So if the model needs facts, documents, or current information, it must call a tool that can provide it. Common examples of information tools include search APIs for live information like news, prices, or weather; vector databases for retrieving documents using semantic search; product or policy databases for company-specific knowledge; code search tools to find relevant functions in a code base. With information tools, the model can pull in external knowledge on demand and then use that information to produce an accurate answer. This is what turns an LLM from just a text generator into a system that can reason with real-world data. The second category is action tools. Information tools only return information. Action tools let the agent actually do something in the world. Examples of action tools include sending an email, creating or editing files, scheduling a meeting, triggering an automation or workflow, running code or scripts. Here, the model's output is not an answer, it's an action. The agent calls the tool with structured parameters. The tool executes externally and returns a simple result such as email sent, report generated, deployment started. Action tools are what move agentic systems from conversation to execution. They allow AI not just to tell us what should happen, but to make it happen. When an agent calls tools, or when its output will be consumed by another system, free-form text is not enough. We need responses that are predictable, machine-readable, and ready to parse. This is called structured output. Structured output forces the LLM to return information in a specific format, usually JSON, or a defined schema. This makes tool results reliable, prevents ambiguity, and allows automation. For example, a code executor needs arguments and variables, not a paragraph. An email sending tool needs clear fields for to, subject, and body. A meeting scheduler needs a date, time, and list of participants, not a story about the meeting. A payment tool needs an amount, currency, and a recipient, not a friendly explanation. Most modern LLMs can enforce this directly. So instead of free-form language, we get responses the agentic AI system can act on. Structured output is what makes multi-step tool use, chaining, and autonomous workflows possible. Tool use is a key method that allows agentic AI systems to use language models but do a lot more as autonomous agents and at the same time stay relevant and up to date. With access to external tools, the model is no longer just answering questions. It can retrieve real-time information, take actions, and complete tasks autonomously. In this video, we covered what tools are and how they are defined, how tools are invoked and used by the system, the difference between information tools and action tools, why structured output is essential for reliable tool use. These building blocks expand what language models can accomplish, and they are essential for building practical agentic systems.